today I have been assigned to take 3 topics. So theory of hypothesis is there, then we have Anova, and we have index numbers. Okay. So I have made 3 different presentations. For the index number, I haven't made presentation. Directly, I have taken one PDF from this National Institute of Open Schooling. That is sufficient. And for that, what is required to be added, that I will explain you on the slide, on the presentation itself. You people can note on that also. So with that, we will start. So theory of hypothesis. Okay. Initially, the slides may take little time to move. Okay. Yeah. So terminologies are there for every particular concept. There will be certain terms. So I have started here with terminology. I think these terms might have been explained by previous educators before, but still I have taken it to make sure that there are 2 terms. Okay, the term like yeah, the terms are population and sample. Now here there are 2 related terms. For population, we have something called parameter. Okay, and for sample, we have something called statistic. Now it is very important and very basic to understand the difference between population and sample, and parameter and statistic. Most of us know what is difference between population and sample. Okay, sample is a representative taken from the population, because every research cannot be done on the whole population. We try to take it on the sample, we work some methodologies on sample, and then we try to generalize, or we would like to estimate for the population. Now parameter is something, the characteristic features related to population, like population mean, population standard deviation, population variance, all those things, population range. And statistic is something which is related to sample, like sample mean, sample variance, and all. So here we use all capital letters, here we use small letters. In statistics we use small letters. Okay, so that is what it's written here in parameter, in statistic. I will not be reading these definitions for your reference, but I have told the same thing here. Okay, and we have something called estimator. What is estimator? Estimator is a statistic. This you should remember. These questions will be asked very simple and very directly in exam. Okay, estimator is a statistic. Why? Because it is obtained from sample, and using this estimator we try to forecast the value of parameter, or estimate the value of parameter. Okay, forecast is something outside the population range. Means if we are trying like 2001, 2000 or 2020. Okay, from this we have taken a sample, and we have found that the mean temperature is 28 degrees Celsius. Now we see that the population mean temperature is around 29 degrees Celsius. Okay, so this is statistic, this is population. This estimation of 29 degree, this is taken from here. So this X, which is sample mean, is known as estimator. Now what is forecasting? Forecasting is trying to identify what is the mean temperature in 2030. It's outside this range. What we try to estimate based on this sample is called as forecasting. Why I am telling this question? Because one question is there, the difference between prediction and forecasting.
Hello, sir.
Yeah.
Can you please start the PPT, sir? Like
PPT is not visible?
it is
Sir, it's
visible, but
visible.
it's only on first slide.
Yeah, on first slide only I'm explaining. Can you see this words prediction and forecasting?
No, sir. Only it's theory of hypothesis by Sharath.
Okay. Fine, I understood. Thank you.
Now it is visible, sir.
Terminology is visible.
Yes, sir.
Now, is it visible in the complete this slideshow mode?
Yes, sir. Yes.
Okay, so till now what I had written, you have people haven't seen.
No, sir.
I was writing something like this. So have you seen that or you haven't seen? I think you haven't seen
No,
because
no.
the slide itself was not visible.
Yes,
No
sir.
problem. See, what I was trying to tell you is simple. Okay, 1 second. I was trying to explain you the difference between population, statistic, and parameter and statistic. And I was trying to explain the difference between prediction and forecasting. These are usually asked questions. Okay. So parameter is something related to population. Statistic is something related to sample. So when a statistic is used to estimate the population, then that is called as estimator. Here it is, estimator. Okay. Now what is prediction? Prediction is when we use to identify the value within the given range, like 2000 to 2020, whatever we try to find the value from sample, we try to estimate for population. This is prediction. But if we try to observe the value for 2030 on the basis of this sample mean, then that is called forecasting. See, forecasting is very important tool and very big research area. And why forecasting is important? Because here you don't have sample. Between 20 and 2030, you don't have sample. But based on 2000 to 2020, we are trying to identify. That is why it is called forecasting. Okay. So the words which will be given in option is in sample and out sample. So can anyone tell that whether this forecasting is in sample or out sample?
So it's out sample.
Very good. It's out sample. So this is one very good MCQ. Here you need not to spend time. Directly you can click and go. Okay. So now next slide is visible sampling distribution.
So again in slide number 2.
The sampling distribution is not visible.
No, sir. Second number slide only is showing, sir. Terminologies, parameter, statistic, estimator, and estimate.
It is happening.
So you may play the slideshow like that.
Now you are seeing sampling distribution.
Yes, sir.
Okay, I think when you are going to slideshow, it is getting stuck.
Yes, sir.
I'll do one thing. This time, once more, I will try. If it is happening, then we will not go to slideshow more. Okay. So now you are seeing sampling distribution slide.
Yes, sir.
Okay, fine. See, sampling distribution here,
Sir,
nothing more.
just one try, sir. Change to the next slide. It's working or not?
Okay, sure. That is okay. Now, can you see standard error test of significance?
No, sir. It's again stop.
Okay. So basically, I think we'll share it one more time. Now, nothing is visible, I think, right?
So still in slide number 3. It's...
Sampling distribution.
Yes, sir.
Okay. And now, is it in a slideshow mode?
No, sir.
Here it is coming for me. Message is paused. I don't know why it is paused actually, but Now is it came?
No, sir, not seeing in slideshow.
Are you able to see?
So we are able to see on sampling distribution only.
And next slide,
No, sir.
the standard error unable to see.
No, sir.
Oh my god.
Yes, sir. Now it's visible. Standard error, test of
Okay,
significance.
okay. So I will do one thing. Actually, I can explain like this also, but I thought
Yes,
if
sir, it's
slides
okay,
show
sir.
more is there, it will be more visible clearly.
Mhm. No problem, sir. We can zoom it.
Yeah, we'll. Okay, no problem. So what I will do, it will be little more pain, but it's okay. I will try to zoom in and zoom out every time.
Yeah, yes, sir.
Yeah, because. And if I forget, please in between remind me. See, actually, sampling distribution is nothing but we are taking all the samples which are taken and we are trying to see what how it is distributed. Because see, we have two words known as normal distribution and non-normal distribution. Okay, I think we all know that this is called normal distribution, and anything apart from it is called non-normal distribution. Okay, this is unimodal, this is bimodal. So for that we have to know sampling distribution. Sampling distribution refers to all the sample characteristics of the taken sample. And an exam, this is the set of values of statistics obtained from each sample is called. Here you are thinking that it is easy, but see their options will be like statistic, estimator, sampling distribution, and one more word is sampling space. So you have to know what is the difference between these things. Sample space is what it just collection of the whole, all the values are in a sample. That is called sample space. This is the term related to probability. Okay, probability, sample space. Sampling distribution is related to each sample. Okay, and here you will see the word statistic. So after this presentation, when you are preparing for any exam, when you see the definitions, try to identify the key values. If they say the complete set of values, or if they use the word universal set of values, then they are trying to refer to something called sample space. Okay, and if it's just the set of values of statistic obtained from each sample, then they are referring to something called sampling distribution. Okay, this was asked around in I think 2018, 2017 ARS main certification, which was including 2018 ARS net notification. So those people who applied for net, it was 2018 net. Okay, in that this question was asked. Now standard error is visible, or I should go back?
No, sir, it's not visible. Sampling distribution. Yes, sir. Now it's
Standard.
visible.
Now it is visible, right?
Yes, sir.
So I think it's better to continue here only. But only thing is I may not be able to use pointer, I think, or pointer is available here. Okay, fine. So standard error is what? The standard deviation of sampling distribution of a statistic is known as standard error. Usually I will not tell to memorize, but memorize this particular definition. Because any person who is asking for you, he will be expecting the same language from you. It may be an interview or maybe an exam. So the standard deviation of sampling distribution of a statistic is called standard error. Okay, this is clear MCQ. Now test of significance is there. It means you have to see whether the hypothesis which you have taken is right or wrong. So till now it was everything about a little brushing up the general knowledge on the hypothesis theory portion. Now we'll come to what is known as hypothesis. Hypothesis is a definite statement. Okay, it is not a tentative statement. Tentative statement comes in probability. Definite statement comes in hypothesis. Definite statement, next important word is about population parameter. It is not about statistics. It is not about sample. It is about population parameter, which you want to verify on the basis of sample. So the question will be that hypothesis is related to population parameter, sample statistic, whatever they will ask. The answer is population parameter. Now, what is simple hypothesis? Simple hypothesis is when it covers all the variables given in the population. Like if population is having both mean and variance, and if both is included in the hypothesis, that is called a simple hypothesis. And if only one of them is given, then that is known as a composite hypothesis. It is here, okay? What I request to participants is once I will close this presentation and will try to open it completely new. Because if I'll be underlining the keywords, then that will be very much clear to you rather than just telling on the ways, okay? So once I'll close this, now is it visible? Critical region?
Yes, sir, it's visible now.
And
Critical
now in
region.
slideshow mode also it's visible, right?
No, sir, it's not in slideshow
No,
mode.
sir.
Now critical region is visible.
Yes, sir.
I think PPT is angry with me. No problem. See, critical region means what? Whenever we have some values, when we take for hypothesis testing, either we have to accept the value or we have to reject the value. Okay. So when we want to accept the value, then like value means hypothesis. So there should be a region called critical region, where if we get the value, we will reject the null hypothesis. And the other region is called acceptance region. Okay, where we accept the null. See, when we are discussing with respect to null hypothesis. Okay, so don't try to confuse with accept or reject. When we are speaking about null hypothesis, if the value falls in critical region, then we reject the null hypothesis. Okay, why? The basic fundamental law of all the tests we are doing is to reject the null hypothesis. Okay, and when we're trying to reject the null hypothesis, we are trying to see what is the critical region. How we decide critical region? Based on value of alpha level of significance, maybe 95% or 99%. Okay. So critical region is referring to the rejection of null hypothesis. So apart, the opposite of this is acceptance region. Again, acceptance is with respect to the null hypothesis. So don't try to study both null and alternate hypothesis. Study the whole concept with respect to null hypothesis. So in exam, if they give alternative hypothesis, just go for the opposite answer. That's it. So the region of rejection of null hypothesis, when it is true, is the region of critical region. Okay. So two types of error slide you can see, right?
Yes, sir.
Two types of error. Can you see or not?
Yes, sir, it's visible, sir.
Okay. Now here I will go for slideshow mode because here I have to give you one clue. Okay. So I'm giving you people little extra work by telling yes or no for everything. So I'll try to compensate by giving you one simple clue to identify the answer for more 99% they ask this question. Okay. And the question is whether it is type 1 error or type 2 error. This question they asked many times, 99% of time. So here I will give you one simple clue. Here you see except it is 2 times C. Okay. So we go for when we accept 1, 2. When we accept null hypothesis, when it is correct. See, error means what? Either we are rejecting the null hypothesis when it is correct, or we are accepting the null hypothesis when it is wrong. That is error. Okay. Generally, what we should do, we should reject null hypothesis when it is wrong. Okay. So when we accept the null hypothesis, when it is false, then that is known as type 2 error. Here you see 1, 2. When we accept the null hypothesis when it is false, this is known as type 2 error. I think you're understanding the clue, because this table during the exam time may be little confusing. So technically you want to understand here. Rejecting null hypothesis when it is false is correct procedure. Accepting the null hypothesis when it is correct procedure. Okay. But when we accept null hypothesis when it is false is type 2 error. And how we will remember that this is type 2 error? Because there are two C's here. Okay, opposite of this, that is type 1 error. Rejecting the null hypothesis when it is true is type 1 error. Okay, so you have understood now. So I think with this question, no one will do a mistake, I think. So is this clue clear to you people?
Yeah, yes, sir.
Okay, fine. So now level of significance is visible. I think it will be not visible, right? Is
No,
it
sir.
visible? Is it visible? Yes or no?
No, sir.
Not
it's
yet,
not.
sir.
Okay, then this is sure that the null hypothesis of the slide visibility is rejected. You have taken all the samples and seen. So now it is visible, and I think this time it is correct. Null hypothesis. Okay.
Yes, sir.
So visible here, right?
Yes, sir. It's visible.
Okay, fine. So level of significance is type 1 error. Probability of type 1 error is level of significance, which is given by alpha. And what is beta? Beta is probability of type 2 error. Type 1 error probability is alpha. Type 2 error probability is beta. And 1 minus beta is called power of test. Okay. I'll repeat. Alpha is probability of type 1 error. Beta is probability of type 2 error. Alpha is level of significance. And 1 minus beta is power of test. These 4 points are clear. I had told you people to keep pen and note ready. So I had told you alpha, beta, and what is level of significance and what is power of test. Okay. Now next is testing of procedure. This is a theory. You can read it. Just I'm reading it out for your sake. Knowledge of population parameter of interest. We should know which population we are taking, what is the parameter. Then we have to set up a null hypothesis. Then we have to set up the alternative hypothesis. It can be single tail or double tail. If double tail, it should be, if single tail, it should be right tail or left tail. Again, I will tell you when it will come how to remember which one is right tail and which one is left tail. Okay. This is Z statistic. You remember this one Z statistic. Then I will tell you how to remember for Z, for T, for F, for single test, for double test, and for pair test. Okay. But for that, basically, you should remember this one formula. This part T minus estimation of T divided by standard error of T. T is here mean value. Okay. So yeah, when this thing you say take, when the calculated value is less than table value, we say it is not significant and we accept our null hypothesis. Here I will be trying to do with so concentrate here. I will try to do one diagram. With this diagram, I will try to explain. Okay. Sorry. Yeah. I hope you people have seen this diagram in many of the books.
No, sir, we are not visible to see that.
Now screen is not visible.
No, sir, again it's stopped.
Now can you see slideshow mode?
No, sir. I think today it's not working, sir. Slideshow mode.
No, just till now it came. No, again now it's visible, not visible.
No, sir.
I think I will close all the things and again I'll open, because see, this is economics, and economics diagrams and graphs should be done. If I don't do that, then I will not be able to do justice to you. Now slideshow is visible?
No, sir.
No.
No, sir.
Now?
Yes, sir. Now it's visible, sir. Slideshow mode.
Fine. So before again we go for one more technical problem, I will do one thing here. Okay. I will try to explain the things in one diagram. All the things which are there in next 2-3 slides. So now you are seeing slideshow mode, and I think you are able to see the graph.
Yes, sir. No.
Okay. Now
Yes,
you
sir.
see. Okay. Remember this graph, you will be able to answer most of the basic questions. Okay. Now, this is the bell-shaped curve, which shows that the distribution is normal distribution. Okay. And normal distribution's characteristic is the maximum observations will be there around the value mean. This is the characteristic feature of normal distribution. Now, if it is two-tailed test, we have two critical regions. This is a critical region for left-tailed test. This is the critical region for right-tailed test. So this unshaded area is there, no? This unshaded area is area of region of acceptance or rejection. This region is region of acceptance or rejection.
Acceptance.
Yeah, this is region of acceptance. So this is critical region. Okay. Now suppose we take the value of 1.96 minus 1.96 and plus 1.96. Okay. Now what they are saying, the calculated value, if it is less than the critical value, what this is alpha, alpha is the layer of significance. Okay. So now this is the critical value. If a calculated value is less than that, it means it's following somewhere here. It means we accept the null hypothesis. I'll tell you one thing. When you are preparing for interviews, never use the word accept the null hypothesis. There is a research paper which is universally accepted, and they say that this word should be actually not rejected, or we fail to reject. We cannot use the word acceptance. Okay? But if in exam they give, because traditional teachers use this word still today, and if they're using it, then we can't tell it's wrong. So if you are answering orally, or if you are writing the answer, then you should write the word that we cannot reject the null hypothesis. Okay. But if it is an MCQ and they have given the option accept the null hypothesis, then tick for it. So I think you have understood this. So this region is called alpha. Okay. This is 1 minus alpha, this region. This region is alpha by 2. This region is alpha by 2. So alpha is level of significance by definition. By mathematics, it is probability of type 1 error. By graphically, it is the summation of shaded areas. Alpha, beta, and this graph is the favorite part of economists from the statistics point of view. So I'm telling you, alpha is level of significance, definition. By probabilities or mathematical way, it is the probability of type 1 error. And by graphical way, if you want to show, you have to show this shaded area. Complete shaded is known as critical region. So critical region 1 minus critical region is your area of acceptance. Okay, so any doubt how to reject the null hypothesis or how to reject accept the null hypothesis? If the value is falling here, then we reject the null hypothesis. Like I have here second point. If the positive value is more than critical value, means here it is falling, then we reject the null hypothesis. Okay, and if we accept the null hypothesis when it is false, okay, then this is called as type 2 error. Fine. I'm telling you, believe me, if they're asking any question related to hypothesis, then that should be somewhere related to this graph and concepts of alpha and beta. Okay, they may ask alpha plus beta is equal to how much? It is 1. Alpha is level of significance. Beta is probability of type 2 error. And 1 minus beta is test of hypothesis. Sorry, power of the test. Somewhere from these 7-8 points, a question may come. Now, can you see test of significance for last sample?
Yes, sir.
Yes, sir.
Oh my God, finally through. Okay. Now see, we have something called Z test, T test, and F test. So this is what we are remaining from the. So whatever we study for the test of hypothesis, we study these three tests. Okay. So I will not go by slide. I will try to explain them. Okay, together. So first we will go for Z test and T test. Z test and T test are used for two means. When we are trying to compare two means, okay, two mean like this one I'm telling, then we are going for Z test or T test. If there are more than two mean, then we go for F test. This is first difference. Now, how Z test and T test are different? Z test is known as large sample test. T test is known as small sample test. And what is the value for small and large? It is 30. When observations is more than 30, it is Z test. When observation is less than 30, it is T test. When there are more than two mean or two variance, then we go for F test. That is to the Anova. Anova is nothing but analysis of variance, and the test which is used here is F test. Now you people may having doubt that what is chi-square test. Chi-square test is related to goodness of it. Okay, or you can say comparisons of variance. So basically, when it's come for variance, we use for the chi-square test, and when it come for mean, we use for Z test and T test. Okay. So at one go, I think you people may be knowing what is Z test, what is T test, what is F test, and what is chi-square test. So at least basic you understood? Yes or no?
Yes, sir.
Yes, sir.
Now we will go in detail. Okay. Yeah. So now basically we are trying to see what is one sample Z test, what is two sample Z test, what is one sample T test, two sample T test, and there is something called paired T test. We don't have paired Z test, we have paired T test. Okay. So simply one sample Z test means what? We are taking the Z test for only one sample. Okay. And when we are having two samples, it is called two sample Z test. Similarly, if you are taking t test for one sample, it is called one sample t test. If you are taking t test for two samples, it's called two sample t test. Then what is meant by paired t test? Paired t test means what? If we have certain objectives, okay, and we have two samples of the same objective, okay, then these any test done on this is called as paired t test. And how we write it down definition? Definition is when n1 is equal to n2 is equal to n. Means, see, if we have 10 objects and if we are taking observations, then we will be having 10 samples here and we will be having 10 samples here. So n1 is equal to n2 is equal to n. This condition is called paired t test. You need not to by any definition. Paired t test means what? When we are taking two samples from the same objects. Okay, for example, say we will take same 10 students. Okay, same 10 students we are taking. Now we are taking a sample, or you can say same class or same 10 students. Here we are taking sample for their heights, and here we are taken the sample for weights. There is one class. In class we have taken 10 students. For 10 students we have taken 10 heights, 10 weights. So these are the samples from the same object. Then we use what is called paired t test. But if for one class, if we take 10 students and one sample for height, and we take other 15 students for another sample, then we use two sample t test. Okay. But if it is for same sample and different variables, like it is height and it is weight, then what you call it as paired t sample. Okay. Even if it is not different height or different weight, but if you have for same object, the word is same object, then we call it as paired t test. So if it is in sentence question and if they give the like same object or same sample, then we call it paired t test. And if we give n1 is equal to n2 is equal to n, this again they are referring to the paired t test. Okay. So now what you have to remember is this one. If it is more than 30, we call it a large sample test. If it is less than 30, we call it small sample test. Large sample test is also called as asymptotic test. You ignore this spelling. I think asymptotic, one more T will come. Okay. Asymptotic test. This small sample is less than 30. Large sample is Z test. Small sample, okay, Z test, and small sample is T test. Z test, T test, chi-square test, F test, all tests are taken under the assumption that they are normally distributed. If they are not normally distributed, then what we do is we go for Mann-Whitney U test. This is one important test, or we have something called Spearman rank correlation test, or you can say rank test. These two tests are popular non-normal distribution tests. What we are studying T, F, chi-square, F, all these are under assumption that sample distribution or population distribution, sorry, not sample distribution. Population is normally distributed. Okay. So now you can see this slide where I have tried to give you this formula. This formula is very basic formula where we are trying to identify the difference between the sample mean and the population mean divided by, this is standard deviation by root n. N is the sample, number of sample. Okay. This is degrees of freedom. This is n. This is mean and this is variance. Then standard deviation. That is 0 mean and 1 standard deviation. Any doubt till here? First of all, can you see the ink marks?
Yes, sir.
Yes, sir.
It means the slides are working properly. And any conceptual problem till now? Any point you are not understood or something? Okay, if you are silent, I think that you are understood everything, or else everything is going above your head. So I think everything is being understood. So the only difference when we come that standard deviation is not known, then we use sample dash. Here I will give dash because it is a question. Now tell me what is this yes? Whether it is a sample variance or whether it's a sample standard deviation. I'm asking this yes, small yes, whether it is sample standard deviation or whether it is sample variance. We can see the formula. What?
Deviation.
Yeah, standard deviation. Why? How you can tell it is standard deviation, not variance? We can tell it because here you can see root. We know that CV is equal to SD square. Remember this. The same thing can be done. SD is equal to under root CV. So how I usually remember CV is equal to SD into SD. Okay. So basically, when the questions they will ask related to standard deviation, coefficient of variation, they would ask you to calculate this value, and they would have given both, like 4 also, 2 also. The person will forget to take the root, he will click the answer 4. And the person remember that standard deviation is not just this one, we have to take root of it, we will go for the right answer 2. Okay. So don't forget this root. Now this is one sample test. This is two sample test. Two sample test, nothing is there. There only new will be there in one sample. Here you will be having two things, new one and new two. So in the formulas, you have to go on to refer both, like see here they are given x1 and x2 because it is sample. So x1. If it is population, we'll use new one. Okay. So here you have to remember only one definition, that is this definition. From this definition, you can derive all other definitions. Okay. Here, since it is two sample, we have 2, 1. It is x1 bar minus x2 bar. Okay. So this is what all we have for T test, Z test. Okay. Now we have to go for F test, which will come under Anova. This I have kept blank because I had told T test and F test vary only in terms of number of sample. Okay. That is 30. If it is more than 30, it is X. More than less than 30, it is T sample. T test. Okay. Formulas remain the same. One thing. Second, paired T test. What we use is D. D by root n, where D is nothing but xi minus yi. Xi is the observation of one sample. Yi is the same observation of different sample. Like x1, y1 is there, then x1 minus y1 is D. Then D by root n. Instead of using x1 here, x1 bar, we are using D1 bar. What is D1 bar? D1 bar is the difference between the values of the observation. Okay. That's why I have not given anything here. I want you people to take down these formulas from the F test, because if you club all the formulas, it will be confusing. So try to derive every formula by just remembering one formula. That is this one. In this formula, if it is not known, then we will use this one. Okay. And in this formula, if it is for two sample test, then we'll be doing like this. If this is not known, we will replace it by small s. If it is T test, we are using like this. Okay. And paired T test, x1 bar minus x2 bar is there. Instead, what we will do? X1 bar minus y1 bar by sigma by root n. This usually we write it down as d bar. This is called deviation of the mean. So I think you can now be able to derive the formulas of T, F. Are you sure? Now, are you comfortable that you people can derive the formulas for T test,
Yes.
F test, one sample, two
Yes.
sample? Good. Known variance or unknown variance, pair T test, everything you can derive. Okay. So this is the end of first presentation, which was related to the test of hypothesis. Now this second thing, which is related to Anova. If God is considerable, then I think now it should be visible, but it is saying this. Screen sharing is on. Now you can see this slide. Anova means analysis of variance introduction slide.
Yes, sir.
Now slide is changing.
Yes, sir.
Okay, fine. I think someone has kept something in chat box. Okay, it's time to tell yes, sir. Fine. So in Anova, what you should remember, if I'm telling from exam point of view, okay. Why I'm trying to tell from exam point of view, statistics is a very big subject. We know that there is something called BSc in statistics. Okay. Then these people will do MSc in statistics. They will do PhD in statistics. Then what does an economist should know is basics of statistics. Then that is what is called as this sampling, different techniques of sampling, random sampling, non-random sampling, then how to take out hypothesis, null hypothesis, composite hypothesis, alternative hypothesis. Then what are the basic tests like T test, F test, chi-square test. Then he wants to know you the basics of Anova. He does not want you to know complete Anova. Why? The simple reason is it has no significance for economics kind of research. Our researchers are not based on these designs. We don't use research designs. Which people will use research designs? Agronomy people, okay, or plant science people, or entomology people. These people will use designs. We generally go for something assumption of normal distribution. Okay, so Anova is not so important, but this in-depth knowledge is not required. So what they want to know from Anova? Simple questions. Which test is used in Anova? That they will ask. And they will ask you what is degrees of freedom for each test in Anova. And when Anova is used. And what is Anova? So if you know what is Anova, when it is used, which test is used, what is its formula, and what is its degrees of freedom, then the thing is done. Okay. And you should know the terms like explain the sum of square, total sum of square, and residual sum of square. If these things you know, then you need not to know anything more about Anova. But I'm telling you, Anova itself is a very big chapter. Okay. So I'm trying to tell you that what is Anova with simple things. Here you see, we have so many data like 1, 2, 3, 4. If it was only 2, we would have used T test or F test. Since it is more than 2, we are using Anova. So what is example here? Like we are taking different type of T's. So you know that in T's there will be different types. It's not only 2. If we want to have only 2, then we should have only white tea and green tea. Or you have to do white tea and non-white tea. Then we can restrict for 2. But when you're going in detail, no tea, white tea, green tea, peppermint tea, lemon tea, honey tea. You know, there's something called this one. I think safflower or saffron tea. Okay. So all the different type of teas are there. Then when you want to study the effect of these teas on the weight loss, then we can't use t-test, we can't use f-test, we have to use f-test we have to use, which we use in Anova. So when we try to study mean of more than 2 samples, or when we want to study the variance of 2 or more than 2 samples, then we use Anova. Try to remember. Variance of 2 or more than 2 samples, or mean of more than 2 samples. Because if mean of 2 samples we are using, we could have gone for t-test or f-test. More than 2 sample mean, we are going for f-test. Means it is Anova. Okay. Now, what is within group variability and between group variability? See, whenever we are trying to study the correlation, or whenever we are trying to see difference, we have to trying to see the significant difference. These are the terms: significant difference, or we are trying to study the correlation which is not spurious. Spurious correlation is what? That whenever what do you say? Like we think that if today, like if today it is raining, then we may or may not get some snacks. Like these things may happen or may not happen. They are not preparing snacks because it's raining. They just prepared it and we are trying to link it. So such relations are called as spurious correlation or nonsense correlation. Another example is if there is volcano in one country, people are dying in other country. This is nonsense correlation. Nonsense correlation is a term in statistics. Okay, I'm not simply using nonsense correlation, or the better word is spurious correlation. So within the group variability, whatever is happening, this usually is taken as chance difference. Okay, and when this between the group variability is more than this within group variability, we say that this variability is significant. The whole fundamental idea of using Anova test is just to know whether the between group variability is more or less than within group variability. If it is between, if more than within, then it is significant. That is, our test is correct. If it is less, then no problem. Then it's of no use. Okay. So we use between sum of square, mean sum of square for between, divided by mean sum of square within. And if this is f test, okay, this is only f test. And if it is more than 1, then we say yes, there is significant difference in variance. I'll explain you one more time. Okay, I understood that it might have confused people. I will explain one more time. See, f test which you are using Anova is nothing but we are trying to compare the ratio of mean sum of square between the sample by within the sample. Okay, if the variation, MSS is nothing but measure of variation, mean sum of square. So if the variation between the sample is more than the variation within the sample, then obviously this ratio will be more than 1. And if it is more than 1, then our null hypothesis is rejected. What will be null hypothesis? That mu1 will be equal to mu2 is equal to mu3. And if it is more than 1, it means they are not equal, and hence we reject the null hypothesis. Okay. This is what the crux of Anova. Between should be more than within. If you remember this thing, everything else you can. Formula is based on this, definition is based on this, statistics are based on this, everything is based on this simple relationship. So when I say within, I was referring to this unknown causes, error sum of, or you can residual sum of squares. Okay, this is between the sample, which is because of certain treatments which we give. Okay, And remember this point, R.A. Fisher had given this ANOVA. And we are using the word several mean because we are referring to more than two. So this is outline of ANOVA. Degrees of freedom, sum, mean sum of square, F ratio. Here you see known causes means between. Unknown causes means within. This you take ratio if it is more than 1. F ratio. Here usually you will try to take the critical value, but for outline you remember that if it is more than 1, it is significant, okay, or if it is less than 1, it is insignificant. So ANOVA table principle, ANOVA table secret, have you understood what is ANOVA, why it is used, what we are actually trying to do in ANOVA? I am asking you, have you understood ANOVA?
Yes, sir.
Understood now. See, even if you see definition, it is here. ANOVA is technique of partitioning the total variability into known and unknown. Means total variance into between the group variance and within the group variance. This is the simple crux of ANOVA. Okay. So rest all is just for your reference. One way ANOVA, if you are trying to take only one variable, like if you are using any one particular fertilizer and you are trying to read about, here the feed is there, feed, fertilizer, anything you take. If you are trying to see only its impact, then it is one way. If you are trying to take more than one, like K fertilizer and J feed, or this fertilizer and this insecticide, if you're using two things and you're trying to study, that is two-way ANOVA. So that is simple thing. One-way ANOVA, two-way ANOVA. There is something called random effect model and fixed effect model. This is not so important, they will not ask. But remember one thing, just in fixed effect model, this difference will be constant. You are here, it is there. This, the difference between the sample mean and population mean will be constant. That is fixed effect. It's fixed. And when you are trying to do something with the samples, when you take a random sample and then you try to estimate the ANOVA, then we call it as random effect model. This is only for those time series analysis who are doing. For them, I'm telling these two words are there, but it is not so important from the point of this NET exams and JRF exam. Okay. So this I'm telling. If you are trying to see the 1, 2, 3, and 4, we are using fixed effect because we are knowing which treatments we are using. But if there are so many, among them few you will take and do, then we call it as random effect model. And in fixed effect model, remember, this is constant. The difference between the population mean and the sample mean is always constant. It is fixed. So rest everything is just I'm telling you, these are all our formulas, and these are we have to just mark it up. There are nothing to explain these things, okay, but I have made it so that the people who want to read can go and read. So here I told this is treatment sum of square, this is error sum of square, or you can say residual sum of square. Error or residual are same. This is total sum of square. Okay, here k minus 1, n minus 1, n minus k. This is how you have to remember. I'll give you a clue how to remember this. Remember that for total it is always n minus 1. What is this n minus 1? Degrees of freedom. What is this one? One is the population mean, because we already know population mean. So we are subtracting population mean from the whole number of sample, that is degrees of freedom for total sum of square. Now error sum of square. What is error sum of square? From the total population, we are subtracting the known population or known sample. The remaining thing is error sum of square. And what is treatment sum of square? We know the sample observation Among them, this one is already removed, that is sample mean. So remaining is sample degrees of freedom. I'm repeating. For sample, we have like N1, N2, N3, N4, we have N10. We don't know these samples, but we know that we know the value of its mean. So 10 minus 1, remaining 9 we don't know. This is degrees of freedom. K minus 1, K is related to sample. Minus 1, what is 1? Okay, I think it became confusing. What is 1? 1 is sample mean or sample variance. K minus 1 is degrees of freedom for treatment. N minus K for residual, because outside the sample and within the population, what we don't know is residual. Total N minus 1. N is population and this is population mean. This is total sum of square. So this is between and this is within. When we take its ratio, it is F test. This all you have to remember. Critical difference. Critical difference term you have to understand. The definition is that when we want to know that among these 10 pairs, okay, there are 10 pairs, like 1, 2, 3, 4 until 10, and here 1, 2, 3, 4 till 10. We know that they are significantly varying. But among these, which are the pairs which are most contributing? You see, you have to know that which pairs we want to know individual pairs, then we have to calculate least significant difference. This they will not ask you formula, but remember, when we want to identify which pair in the sample is contributing for the most differences, then we go for critical difference approach. So remaining all these things you can go through. Okay, one example, two sample. I said two sample means what? We have two treatments, feed and fertilizer. If you know only feed or only fertilizer, it is one-way ANOVA. Feed and fertilizer, it is two-way ANOVA. Only temperature, only rainfall is one-way ANOVA. Temperature and rainfall is two-way ANOVA. Okay. So anything you people want to ask about ANOVA? Or anything you want to ask about hypothesis testing, you people can ask. The last topic remaining is index numbers. That I will take now. If you are having no, if you are not having any doubts, I'll start with index numbers. Here I'll be giving you 2 minutes break, 2 to 3 minutes break. Think, go to what means, try to recollect what all I have told. If you have any doubt, you people can ask, or else you people can at least write down in the chat box. Okay. We'll start the next chapter, that is last portion of this class, in 2 to 3 minutes. So there are no doubts. Shall I move to next last portion of this class?
Yes, sir.
Okay, the last
Hello,
portion
sir.
is, yeah,
Hello, sir.
yeah, please tell me.
So I have one question. So, what exactly why we're using Anova to find what we are finding sir through Anova
Okay.
exactly in simple form.
In very simple form, in ANOVA, we are trying to study the mean and variance. Okay. Difference between means or difference between variance of samples. Now, when it comes to mean, it should be more than two mean. How the difference between more than two means is significant or not significant? We use ANOVA. Or if it is between two or more than two variance, we are using ANOVA. Got it?
Okay, sir.
Okay. Why we need to study means is we want to know whether the difference between the values in the groups are they really significant or they're insignificant. Insignificant means maybe because of unknown terms. If it is spurious correlation, then it's no need to study. If it is significant, then only it is useful to study. That's why the whole MSc research and PhD research is all about getting the significant difference. Yeah. So now I'm trying to show you one notes. Okay, one notes on index number. This already I have made to the person. So can you people see this index number?
Yes, sir.
Yes, sir. You can see.
Yeah, I will also try to put it in chat box. Wait. Whenever you have any problems with these things, one of the best material you will get from NIOS because it is from government side and people who are preparing it mostly they are from this DU University professors. Okay, so they are good at it actually. So I have shared it in this one chat box. Now you can open it and you can follow me here. But basically, I think if you see the screen, that is enough. You need not open it now. So see, this is about index numbers. Why I'm giving about index number is most of us don't have exact notes for this. I have it because I prepared for multiple exams, and so I have took it from different sources. Many of us will not be having. So what I want to remember you, make you people remember is what all these things are important in index number. I told you initially to take pen and paper this for this particular chapter. Okay. So write down certain questions, means key things from index number. We should know what is the definition of index number, how index number is different from averages, simple averages. Okay. What are different type of index numbers? Among these, what is last payer's index number? What is partial index number? Don't worry about spelling. It will be coming in this presentations. Okay. I'll explain everything, but overview I'm giving. What is last payer in the this index number and purchase index number, and what is wholesale price index and what is consumer price index? What is basically difference between them and why India has shifted from wholesale price index to consumer price index? Okay. So in index numbers, we have to know only these things. This is very small concept. So index number, as I see here, last payers price index, purchase price index. Don't worry, I'll be explaining it down. So I think you people can see the scrolling pages.
Yes, sir.
Yes, yeah. Sir. So here there is meaning of index number. The most important definition is here. Index number expresses the relative change in price, quantity or value compared to the base period. Why I have given highlight this particular definition is here. Right here. I think since this is different. I think here I cannot write, but no, here in writing also not so necessary. What you have to remember is Yeah. Whatever, if it is changing with respect to price, then it is called price index number. If it is quantity, it is quantity index number. If it is with respect to value, it is called value index number. Okay. Now we will study only with respect to price. Why? Most of our economic studies are all turning around the effect of price forecasting, price inflation, inflation trend, everything is on price. Okay. So whatever I'll be explaining with respect to it will be with respect to price. Just if you replace the word price by quantity, it will become quantity index number. If you replace quantity by value, it will become value index number. Okay. Now, there are two terms here, simple index and composite index. Now, if you remember, we had simple hypothesis and composite hypothesis. Anyone remembering what is simple hypothesis?
So we take both means and variance of that in
Yeah,
simple.
good. We take all the variables present from the population. Okay, there it was only two, I told two, but if there are more than two, we have to take all the samples. Very good. But what is simple index is, here we are trying to study only one variable, that is simple index. If you are trying to use more than one variable, then it is composite index. Okay, so try to make difference between simple index and composite index, and simple hypothesis and composite hypothesis. Okay, they are little difference. Next is, what is difference between a simple index number and an average number? Okay, here average number means what? We have a continuous roll of data, we are just taking average from that data. Like we have, say, 1 to 10, what we will do, 1 plus 2 plus 3 plus 2 till 10 divided by 10, that we take it as average. But what is index number? Index number is, we are taking it as two different regions or two different time periods, or for two different set of basket of goods. It is completely two different, they are not one. For example, if one series, if you are taking average, then that is average or mean. But when we are taking for two different things, that is index. Why we take index? We take index because we want to compare it. See, if we want to compare today's price level with the independence time of price level, or with the 1999 price level, we can't compare. We can't compare today's 1 rupee with that day's 1 rupee. Today's 1 rupee, we don't get chocolate. That day 1 rupee, we used to get everything. But how to compare this 1 rupee? We convert them into the index. We convert them into index and then we compare. Then we see that that day's 1 rupee is equal to today's 150 or 200 rupees. I'm just giving a random example. Okay. So we use index numbers to compare the values at two different time periods. We take, even today, we can't compare our rupee with the America's dollar. What we do? We convert it into an index, maybe exchange rate or purchasing power parity, and then we compare. Okay, we tell that our 1 rupee, our $1 is equal to our 72 rupees. We are comparing. Why? We are following a norm called exchange rate. We may also follow something called purchasing power parity. So index numbers are used to the comparison. Index numbers are from the different price levels or different scenarios. This is how index number is different. Okay. So we have characteristics. They are special type of average, which I told already. Then they are shown in terms of percentage. Obviously, any ratio we will take it as percentage only. Then they measure relative price change. Okay, over a period of time or between the places, as I explained, between now and independence period or between two different countries. This I have told how it is useful, that already, maybe inflation or maybe to do DA. Remember, for DA we use wholesale price index of laborers. Okay, that is how it is used. For DA, you remember, just wholesale price index for laborers is used. So purchasing property, you can go through this. It is for writer exams, but as I have been told, for ARS, NET and HRF, objective will be there. So I don't think they'll ask questions from here. Now coming to this thing. What are different type of weight index? Weighted and unweighted. Okay. In weighted and unweighted, we try to see, I'll do one thing. Here I cannot write. So I'll open in PPT and in one slide I'll try to explain these things. Okay. Are you able to see PPT? You are able to see PPT slide?
No, sir.
No, sir.
No, sir.
I have tried to open one PPT slide. I think you are seeing, okay, here. I will stop this. I will stop this, and here in new share screen, I will take out one slide. Now you are able to see one slide?
Yes, sir.
Yes, sir.
Slideshow of that slide? One second. It will come. Can you see slideshow of this slide?
Not yet, sir.
Not it.
No, sir.
I'll try once again because this is the last part, so I want to explain it properly. Now you're able to see one slide, right?
Yes, sir. We can see the slide.
And now I'm doing it slideshow. Now are you able to see slideshow?
No, sir.
Now?
No, sir.
I think in presentation, some other presentation might be open. I will do one thing. I will shut down all of the things. Yeah. So now you go to this one, share screen. You are able to see one slide, and now I'm trying to show the slide. Now can you see the slideshow? Means empty slide.
No, sir. Slideshow is not
Sir.
visible.
An empty slide is not visible.
Sir, empty slide is visible, but not the slideshow.
No, this, yeah, I have maximized the empty slide. Now I will write on this slide. So once again, are you able to see this pointer?
No, sir.
What I'm writing here, unable to see it.
No, sir.
Now,
Sir, no.
fine. So I will start explaining, and when you can see the slideshow, you can tell me. That time I'll writing also. So there are different type of index numbers. Okay. Index numbers are based upon, weighted average, non-weighted average. When we say weighted average, we are trying to measure it with respect to some quantity, like base year quantity or current year quantity, different things. Okay. But when we are trying to like do from consumer price index or wholesale price index, we are concentrating on the methodology. Okay. So what I will do, I'll first tell you the different type of index numbers, and then I will tell what is the consumer price index and wholesale price index. Okay. So there are unweighted and weighted. In unweighted, we have two types. One is simple average and a simple aggregate index. See, this is not very important. I'm telling you because index numbers, they just want to know the basic things. Now, can you see the slideshow? This empty slide with this maximized.
No, sir.
No, sir.
Okay, I will try to do this whiteboard. Can you see whiteboard?
Yes, sir.
Ah, okay. So I'll try to do from here. Now see what I was telling you. Index numbers are there. In index number, we have two types. One is unweighted. Second one is weighted. Okay. In weighted, we take certain value of maybe price or quantity or value. We try to measure current scenarios with them. In unweighted, we take simple averages. In unweighted, we have two things. One is called simple average. Okay, these things you will get okay in PDFs and all, but try to understand it because it's a very big chapter. I'm doing it very small. Second one, we have something called simple aggregate index. Simple aggregate index. In weighted, we have last buyer, we have next past share, we have DBM, Dosh Bowley method, we have Fisher method, then we have Kelly method, finally we have Marshall and Edgeworth method. I did not give you formulas directly, and I am taking this pain to explain because if you see formulas, you may forget it. But if you remember how formulas came, then you will never forget it. Okay. So this is simple. PT by P0 into 100. Current year price divided by base year price into 100. Any doubts in this? In simple average, any doubts?
No, sir.
Okay. So we are starting from simplest of simple. That is, we took current price by base price into 100. This is simple average. Now, when you take its summation and divide by n, this is your simple aggregate index. Aggregate means what? Or final percentage. You know, this is like simple average is like your subject marks, and your aggregate index is your like your CGP or OGP. Okay, where you take everything. So any doubts in unweighted index number? What is simple average and what is simple aggregate index? How to calculate it? Any doubts in these two things?
No, sir.
No. Okay, fine. So I will try to remove all these things. Okay. I'm telling you concentrate here because now if you concentrate, you need not to behind this. You will easily understand how they are done. And to understand how it has come, we have kept so much of already say hard work. So I don't want you people to keep hard work. Last year is under weighted index. Okay. Weight means what? We have PT by P0. This is common for everything. Now to this we have certain weightage. Last year you remember as last. So last year price index is PT by P0 into Q0 by Q0. This is your weight. What is weight? Weight is base year quantity. This is simple average. This is the weight which you are using. Since you are using base year quantity, we are telling it as last year price index. Any doubts here? What is the formula of last year price index? It comes like this: last year price index. Last year price index of base year of year 1 with respect to base year 0. Or you can say base is always 0. If it is T, we write last year price index of T with respect to base 0. If it is 1 or 1, last year price index of period T with respect to period 1 is PT by P0 into this is the weight Q0 by Q0. So when it comes to base year quantity, when base year quantity is used as weight, then what you get is last year price index. Any doubt here? Any doubt here? I'll be going on deleting one by one. Any doubt, or shall I remove? Are you understood last year price index?
Yes, sir.
Okay, fine. Now coming to Pache. Now what is Pache? Here I told everything is a price index number, just weightage will differ. Okay. Here again PT by P0, but in Pache we use present quantity as weightage. So it is Q1 upon Q1 into 100. Any doubts? Price index of Pache of 1 here is like this. Have you understood? Just current year quantity is taken as weights. This is your Pache index. Pache price index. I hope you're understanding.
Yes, sir.
Okay. So last year is and Pache. These two are very important. Okay. Now next coming is DBM. Now what is DBM? DBM is nothing but that is, it is arithmetic mean of Pache and last year index. Understood? So what will be its formula? Formula will be P1 by P0 into Q0 by Q0 plus P1 by P0 into Q1 by Q1 divided by 2. That's it. This is your DBM. DBM, you remember it is AM. Here B is there, so I remember A. So DBM is ABM. You should be able to write all these formulas without any books, without anything. Just how I have taken one open slide is there. If open slide is there, you should go on explaining. Like this, if you can do, then you are thorough with the portion and thorough with the subject. Okay. So I think DBM is also done, right? Understood? DBM is the arithmetic average of last year and past year index. Okay. Okay or no?
Yes, sir.
Yeah. Then next is Fisher ideal index. Fisher ideal index, remember one objective. Fisher ideal index is the ideal index because it passes the factor reversal test. I will explain what is this. Okay. Factor reversal test and time reversal test. Since it qualifies both of these tests, we call it as an ideal index. Okay. Now, first thing first, what is Fisher ideal index? It is the geometric mean of Pache and last year price index. Pache and last year price index. Geometric mean is Fisher index. Understood? And what is time reversal test? Time reversal test is P10 into P01 is equal to 1. Means if we take the index at opposite time intervals, then they should come as 1. What is factor reversal? When you take price index with quantity index, the value should be equal to the value index. Because you know price into quantity is value. Any test which passes both of these tests is called ideal test. And this ideal test is nothing but Fisher's test is ideal test. Okay. Therefore, we can remember the name like Fisher's ideal test. So what is Fisher test? It is geometric mean. Why it is ideal? Because it qualifies these two tests. What are these two tests? I have written here. Which test is ideal test? Is Fisher test. Any doubts here?
No, sir.
Now last remaining is two. One is Kelly, other is Marshall. Kelly is very simple. You take any constant number. Here now we are taking Q1 or Q0, right? He told take any constant number like Q. And when you do it like P1 by P0, into Q upon Q. This is Kelly. How you remember? Kelly for K for constant. Okay. And finally, we are coming for Marshall. Marshall will tell either take total or arithmetic mean of Paasche and last pair. That is L plus P or L plus P by 2 as weightage. Okay. Now I'll explain you by formula. P1 by P0, Q0 by Q0 plus P1 by P0, Q1 by Q1. This is your Marshall. Or if you take whole divided by 2, it can be Marshall. Again, first one was total. Now this became our average. So this is your Marshall index number. Any doubts? So this is everything about index number. Okay. For extra thing, I will tell you CPI and WPI. What are the difference? In CPI, we include both goods and service. Here we include only goods. Both CPI and WPI is last pairs index. Okay. How they differ is in this methodology. Here both goods and service. Here goods. Okay. Then CPI we use from this labor. WPI is given by economic advisor. Okay, and this is given by NSO and Labor Bureau. We write it before you used to write CSO, but now it's merged. So we write it NSO. So Labor Bureau and CSO together gives CPI. WPI is given by Economic Advisor, Government of India. This is by Ministry of Commerce. This is Ministry of Statistics and Program Implementation. This is Ministry of Labor that we are doing. Then from 2014, we are using CPI. Before we used to use WPI. Why? Because the fluctuation in food is more prominent in WPI. And if so much fluctuation is there, we can't make proper policies. So we have shifted to CPI. And CPI is in terms with the international norms. So when we made terms with IMF, we told that we will slowly realign all our methodology with the standard practices used by IMF. These practices called as standard practices. So in that step, we try to shift from WPI to CPI. So this all everything I had to done. So any doubts, anything you want to ask, people can ask. 11 to 1 was my timing. I have stopped 15 minutes before so that we can discuss anything you want. I have not included this all indexes in the end because it is not the part of net exam or other exam means a JRF at least is not there in JRF exam. But I explained to people because if they are writing ARS mains exam or if you are giving PhD entrance of IARI or any India any other exams, they may ask this question. Okay, so basically you should remember CPI, WPI, and last pair and past year. Last pair, as I told, last pair, last. Past year, present. So here present quantity is the weight and here past quantity is the weight. Last pair is used to see the price trend. Why? Because quantity is constant, so whatever is the change is due to price difference. Past year is used to study the consumer behavior, or you can say consumption pattern. Why? What was consumed in base year and what is consumed in present year can be studied here. Here you are taking today's presentation, no? Today's consumption. So we are able to see how consumption pattern has changed. So that is what we see from past year index. Any other doubts you may ask. I stopped my presentation here. Anything you people want to ask, you may ask.